The war had been over for exactly 1 week. Soldiers were boarding trains home, governments were counting bodies, and deep inside a workshop in Leningrad, a group of Soviet engineers sat down and began designing something that would make everything that had just won the war look obsolete. On September 9th, 1945, 7 days after the Japanese surrender, the Soviet military authorized Project Object 260. The vehicle would be designated the IS-7, named after Joseph Stalin. The war had ended, but the competition had not. The Americans had the atomic bomb. The British had the Centurion. The Soviets had Nikolai Fyodorovich Shashmurin, a tank designer who looked at everything the war had produced and decided none of it was good enough. 3 competing designs had been developed at the Leningrad Kirov plant during the final months of the war. Shashmurin's team took the strongest elements from all 3 and merged them into a single machine. Not a compromise, a synthesis. The armor drew from the IS-3, the tank that had stopped Western observers cold at the Allied victory parade in Berlin. The IS-7 took that philosophy and pushed further, with 150mm plates set at extreme angles across every surface, engineered to make shells slide away rather than simply absorb them. The cast turret varied from 94mm at the rear to 210mm at the front, with inclination angles between 51 and 60 degrees. The gun mantlet was 350mm of solid steel. There was no anti-tank weapon in any Western arsenal that could penetrate these surfaces at combat range. The IS-7 was not designed to survive being hit. It was designed to make hitting it meaningless. Then came the gun. Matt, and this is where the story gets strange. The original plan called for a 122mm main cannon. The development of that weapon fell behind schedule. The chief designer at the Kirov plant, Kotin, considered the BL-16, a powerful 122mm cannon under development at OKB 172. It fired a 25-kilogram projectile at 1,000 meters per second and featured a loading mechanism capable of 8 to 10 rounds per minute. Kotin personally appealed to military authorities to resume work on the BL-16. The request was denied. So the engineers looked elsewhere, and what they found was sitting in a naval shipyard. They adapted the S-26, a 130mm cannon originally designed to be mounted on warships and fired at enemy vessels on the open sea. They took it off the ship and put it inside a tank turret. A gun built to destroy warships was now aimed at ground targets. It fired a 33.4 kilogram armor-piercing projectile at 900 meters per second. The shells were so heavy that even with a crew expanded to 5 members, 2 dedicated loaders working side by side could barely manage the physical demands. So the engineers installed a pneumatic-assisted loading system that pushed the rate of fire to 6 to 8 rounds per minute. For a gun of this caliber, that figure was extraordinary. The secondary armament was unlike anything ever mounted on a tank. 5 machine guns covered virtually every angle of approach. One 14.5mm KPVT heavy machine gun above the main cannon. 2 7.62mm weapons mounted coaxially. 2 more on the hull sides for forward-facing fire. The IS-7 was not just a tank. It was a mobile fortress designed to engage infantry, light vehicles, wing and low-flying aircraft at the same time it was destroying enemy armor. 65 tons of steel and weaponry needed an engine that didn't yet exist. The initial concept paired 2 V16 cylinder engines working together. It failed during bench testing. The team pivoted to the TD-30, a diesel engine derived from the AC-30 aircraft power plant, an aviation engine pulled out of a plane and re-engineered from the ground up for use inside a tank. This motor pushed the prototype to 60 kilometers per hour. For a vehicle of this mass, that speed seemed physically impossible. It was the kind of number that made people check their instruments twice. The running gear matched the engine in ambition. Each side of the hull carried 7 pairs of road wheels with hydraulic shock absorbers built into the wheel arms. Yet for the first time in Soviet tank construction, the engineers used tracks with rubber metal hinges, reducing vibration and extending track life at high speeds. Torsion bar suspension handled primary springing, while hydraulic dampers controlled oscillation over rough terrain. Every single component represented something that had never been done before on a Soviet armored vehicle. On September 8, 1946, exactly 1 year after the project was approved, the first prototype rolled out of the factory. 3 months later, on December 25th, a second followed. 2 additional hulls and turrets were manufactured purely for ballistic testing, allowing engineers to subject the armor to live fire without risking the functional machines. The IS-7 existed. Now, it had to prove itself. Either the first prototype covered 1,000 kilometers during initial trials without a single major mechanical failure. Engine temperature, transmission behavior, suspension response, track wear. Every metric came back better than expected. Then the second prototype took to the course. It broke down after 45 kilometers. The gearbox seized, the drivetrain locked. The vehicle sat motionless on the proving ground while engineers stood around it trying to understand how 2 identical machines built from the same blueprints in the same factory could deliver completely opposite results. The answer they arrived at would have alarmed any sensible logistician. Instead of simplifying the design to improve reliability, they decided to make the tank bigger. 3 additional tons of steel went into the revised blueprint. The fighting weight climbed to 68 tons. No, the reasoning made perfect sense inside Soviet engineering culture. If a component fails, you do not remove the complexity. You strengthen everything around the failure point until it cannot fail anymore. The hull received a complete redesign. Engineers widened the profile and lowered the silhouette by flattening the turret further. The most dramatic change appeared on the sides. The upper flanks gained a distinctive inward curve that made the IS-7 instantly recognizable from any angle. It looked like nothing else the Soviet Union had ever built. It looked like nothing else anyone had ever built. The curved side armor was not just a visual choice. It was an engineering decision that cost a fortune to manufacture and was worth every ruble. Inside the engine compartment sat the M50T, which was a V12 4-stroke diesel, producing 1,050 horsepower at 1,850 revolutions per minute. It was a tank adaptation of a naval diesel, continuing the pattern the IS-7 designers had already established of borrowing technology from ships and aviation and making it work on the ground. 12 cylinders, 62,400 cubic centimeters of displacement, maximum torque of 4,660 Newton meters. At 15.45 horsepower per ton, the IS-7 achieved a power-to-weight ratio that had no business existing in a 68-ton vehicle. Fuel capacity expanded to 1,300 liters, which immediately created a new problem nobody had anticipated. The curved hull sides made rigid metal fuel tanks impossible to fit. The interior geometry was simply too irregular. So the engineers borrowed flexible rubberized fabric bladders from aviation, containers designed to conform to whatever shape they were placed inside. They weighed far less than metal, fitted perfectly, and seemed like an elegant solution. What they would do under actual combat conditions was a problem the engineers noted and set aside for later. The gun was upgraded too. The S-70 was an improved 130mm rifled weapon that replaced its pneumatic loading system with an electrically powered mechanism modeled on naval artillery. The fire control system automatically aligned the gun with the sight and triggered the shot. Power-assisted electric drives handled traverse and elevation. A crew member was essentially operating a warship cannon through an automated system from inside a tank doing 60 kilometers per hour. The transmission grew from 6 speeds to 8, improving maneuverability while quietly adding mechanical complexity that field crews would struggle to handle without workshop support. By the summer of 1948, 4 updated prototypes rolled off the Kirov plant line. The numbers confirmed everything. 68 tons, 60 kilometers per hour on paved surfaces, 32 across broken ground, not a projection. A fact. The 4 prototypes were transferred to government testing installations operated by the Soviet Ministry of Transport Engineering, facilities designed with standardized courses built to push vehicles to their absolute mechanical limits. Measured road segments, graded off-road terrain, water obstacles, gradient hills calibrated to specific angles. The vehicles that performed beautifully inside factory grounds had a long history of failing catastrophically under the sustained punishment of the state proving courses. The chief test driver assigned to evaluate the IS-7 was a man named Kolchitsky, the senior testing specialist at the ministry. A decade earlier, Kolchitsky had performed what became known as the legendary BT-7 jump, launching a fast tank off a ramp at high speed and sending it airborne before it landed and kept driving. The stunt was filmed for Soviet propaganda. In the years since, he had driven and evaluated virtually every tank the Soviet Union had produced. Nobody in the country had a more refined sense of how an armored vehicle was supposed to handle. His written assessment stunned the evaluation committee. At speeds above 60 kilometers per hour, this 68-ton machine responded to the slightest input on the control levers and pedals. Gear changes required only a small lever movement. The tank obeyed the driver absolutely, tracking straight and following corrections with a precision no previous Soviet heavy tank had ever demonstrated. Earlier generations were notorious for the physical punishment they inflicted. Drivers emerged from extended marches with bruised arms and complete exhaustion from wrestling stiff mechanical linkages for hours. Kolchitsky reported that the IS-7 handled like a passenger car. The driving evaluations confirmed sustained 60 kilometers per hour on hard surfaces and 32 across broken terrain. The tank climbed 30-degree gradients. It forded water up to 1.5 meters deep. Its 710mm wide tracks produced ground pressure of only 0.97 kilograms per square centimeter, lower than many medium tanks, allowing passage over soft ground that would swallow narrower tracked vehicles whole. Then came the armor trials, and what happened during them entered Soviet military testing history. Engineers placed live dogs inside a ballistic test hall, positioning them at crew stations to measure the effects of impact shock, spalling, and concussion on living organisms. The first weapon they brought to bear was the German 128mm anti-tank gun, regarded as the most powerful dedicated anti-tank weapon ever fielded during the war. A cannon that had destroyed Allied tanks at ranges exceeding 2 kilometers. Round after round struck the IS-7 at combat distances. The projectiles deflected off angled surfaces. The armor held, With the dogs were uninjured, the testers escalated. They turned the IS-7's own S-70 cannon against the test hull. 30 rounds of 130mm ammunition struck the vehicle at various angles and distances. The results held. The armor absorbed or deflected every impact. The dogs survived without injury. Raw thickness combined with advanced angle geometry and high-quality rolled steel had created a defensive envelope that the most powerful guns of the late 1940s simply could not defeat. The offensive numbers were just as extraordinary. The BR-482 armor-piercing projectile penetrated 250 millimeters of steel at 500 meters at 90 degrees. At 1,000 meters, 240 millimeters. At 3,000 meters, still 180 millimeters. At 30 degrees, obliquity penetration stood at 205 millimeters at 500 meters, 195 at 1,000, 170 at 2,000, and 145 at 3,000. No tank in any Western inventory carried enough armor to resist these impacts at realistic combat distance. The high explosive capability extended the engagement range far beyond direct combat. At 15 degrees of elevation, maximum range reached 16,300 meters. Over 16 kilometers of reach with explosive shells gave the IS-7 an artillery dimension no other tank in the world possessed. The mechanized loading system performed exactly as designed during sustained fire tests. The IS-7 had passed everything. It had beaten the best guns the war had produced. It had handled like a sports car. It had outrun, outgunned, and outsurvived everything it was tested against. There was just one problem, and it had nothing to do with the tank itself. If you want breakdowns like this, subscribe now. These are the stories they don't put on the placard. With the electric mechanism running, crews achieved 5 rounds per minute from a 130mm naval cannon inside a moving tank. With the system disabled and manual loading only, that rate collapsed to 1.1 rounds per minute. The difference validated everything. Without the mechanized loader, the S-70 was effectively a single-shot weapon in any real engagement. With it, the IS-7 could put 5 armor-piercing rounds downrange every 60 seconds from a gun originally designed to sink ships. The Americans had the M103. The British had the Conqueror. These were the finest Western heavy tanks of the early 1950s, the best the other side could field. Neither could penetrate the IS-7. Neither could survive return fire from it. And neither could come close to matching its speed. Western heavies struggled to reach 40 kilometers per hour, with the IS-7 sustained 60. In every category that tank designers had spent decades arguing about, firepower, protection, mobility, the IS-7 had won. In 1949, the Kirov plant received an official order for 50 production units. 50 machines no enemy could destroy or outrun. The factory began preparations. The future looked secure. Nobody had fully thought through the railway. Soviet military railroads had a strict weight ceiling. Flat cars, bridges, and track foundations across the entire network were rated for 50 to 55 tons. The IS-3 weighed 46, the IS-4 weighed 60, and had already caused headaches. The IS-7 weighed 68. There was no flat car that could carry it, and no standard bridge rated to hold it. The most powerful tank the Soviet Union had ever built could not travel from the factory to the front line. With fixing that meant replacing thousands of bridge spans and upgrading track beds across an enormous country, all to serve a single vehicle type Roads were no alternative. 68 tons crushed surfaces and cracked culverts that lighter vehicles crossed without a thought. Then a prototype caught fire during trials. The rubberized fuel bladders ignited and spread flames faster than the suppression system could respond. Over 1,000 liters of burning diesel and fabric overwhelmed the extinguishers. Millions of rubles reduced to ash by a solution that had looked brilliant on paper. Production economics delivered the next blow. The concave side armor required hydraulic presses capable of bending thick steel into precise curves. Standard factories worked with flat plates using conventional equipment. The IS-7 hull meant retooling entire production lines. The M50T engine demanded precision tolerances associated with marine and aviation manufacturing. The electric loading mechanism contained dozens of individually quality-controlled components. 8 machine guns with 6 remote-controlled drive systems consumed additional production capacity at every stage. Military planners ran the numbers. In the time required to build one IS-7, factories could produce 3 to 4 T-54 medium tanks. The T-54 weighed 36 tons. It traveled by rail without modification. It crossed every existing bridge. It could be maintained by ordinary crews with standard tools. Its 100mm gun handled every Western tank in service. It was not invincible, but it was available in quantity. And the doctrine emerging from Soviet strategic planning valued quantity at a level no single extraordinary vehicle could match. The Cold War was accelerating. Nuclear weapons had altered how both sides planned for the next conflict. Soviet strategists envisioned thousands of vehicles pushing across enormous fronts, exploiting nuclear breaches through sheer numerical superiority. Concentrating resources on super-heavy tanks that could not reach deployment zones was not boldness. It was a miscalculation. The Germans had proven where this road led. The Tiger II at 69 tons created constant logistical crises. The Mouse at 188 tons never left the prototype stage. Both had consumed irreplaceable talent and factory capacity. Soviet planners had studied those failures. Now they were watching the same pattern unfold in their own program. Engineering bureaus tried to salvage the investment. 5 self-propelled gun projects emerged from the IS-7 chassis between 1947 and 1950, each proposing different gun configurations ranging from 130mm to 180mm naval weapons. Every single one stayed on paper. Each had inherited the same fatal weight problem from its parent. The replacement was simpler and uglier, and it worked. The IS-8, later redesignated the T-10 after Stalin's name was scrubbed from military equipment, weighed 50 tons. Less armor, weaker gun, lower top speed. But 50 tons rode standard flat cars and crossed existing bridges without modification. That single practical advantage outweighed every technical superiority the IS-7 possessed. The order for 50 tanks was never executed. The 6 prototypes were assigned to experimental service and spent 13 years driving proving ground circuits, accumulating data nobody urgently needed. Then shaped charge warheads arrived, weapons that penetrated armor through focused explosive energy rather than kinetic force, rendering steel thickness largely irrelevant. The world had moved on without asking the IS-7's permission. Ground attack aviation accelerated the shift. Jet strike aircraft carrying rockets and guided munitions engaged vehicles from above, where even the IS-7 carried only 30mm of roof plate. A single sortie could destroy machines that cost thousands of man-hours to build. Portable anti-tank guided missiles appeared in the late 1950s and early 1960s, allowing small teams to engage tanks beyond 1,000 meters with penetration that rendered heavy armor obsolete as a standalone defense. The arms race between projectile and plate that had driven tank design since the First World War was being overtaken by weapons that played an entirely different game. The innovations did not disappear with the program. Rubber metal track hinges became standard across subsequent Soviet vehicles. The perfected torsion bar suspension with hydraulic dampers influenced running gear design for decades. The electrically powered mechanized loading system proven on the S-70 shaped autoloader development that became a defining feature of Soviet tank design in the T-64 and everything that followed. The fire suppression system, refined after its catastrophic failure on the burned prototype, was installed as standard on future vehicles where it saved crews from identical disasters. The IS-7 was gone, but pieces of it kept showing up in everything the Soviet Union built afterward. The T-54 and T-55 became the backbone of Soviet forces through the 1950s and 60s. Produced and exported by the tens of thousands. Their armor could be penetrated. Their guns were adequate rather than overwhelming. Crew conditions were harsh, but they could be manufactured in enormous numbers, shipped anywhere by rail, maintained by conscripts, and replaced when destroyed. Under a doctrine of mass armored assault, these qualities outweighed the ability to survive 30 direct hits from a naval cannon. Today, a single IS-7 stands at the Kubinka Armored Vehicles Museum outside Moscow. It sits lower than you expect. The turret hugs the hull with an aggressive rake. The gun extends far past the front of the chassis, a visible reminder of its origins on a warship. 8 machine gun positions mark the hull and turret at almost every angle. The curved flanks give it a profile that belongs to no other tank ever built. Every specification on the placard confirms what the testing data showed in 1948. This was the most powerful armored vehicle of its entire decade. The placard does not mention that it could not be loaded onto a train. Historians have identified the IS-7 as one of the clearest examples of a pattern that repeats itself across military history. When engineers are given maximum resources and minimal constraints, they produce something that excels in every technical category while failing the test of practical utility. The IS-7 led every contemporary in firepower, protection, and mobility. It failed in transportability, manufacturability, and maintainability. The 3 qualities that determine whether a weapon can actually function inside a real military, fighting a real war. The Soviet Union recognized the trap before committing to full production. The order died at 50 units on paper. They learned the same lesson the Germans had learned with the Tiger II and the Mouse. But they learned it earlier and at far lower cost. The most powerful tank ever built never fought anyone. It spent 13 years driving in circles on a test track, then retired to a museum where it sits behind a placard that tells you everything except the one thing that actually matters.